In this video, we are going to understand very important concept in software testing and automation, that is BDD, behavior driven development. And trust me, once you understand BDD properly, building automation frameworks becomes much more structured and practical. So what is BDD? BDD stands for behavior driven development. It is a software development methodology that focuses on behavior of the application from user's perspective. Now you might be wondering, what exactly do we mean by behavior? Behavior simply means how a real user interacts with the application, what actions the user performs, and what outcomes the user expects. For example, a user visits the website, logs into the application, searches for a product, adds product to the cart, makes payment, and logs out. Now, this complete flow is called a behavior. However, in traditional testing, we usually create test cases. So, we create test cases around the various features or functionality. For example, in traditional testing, how do we write? Test login page, test registration module, test search functionality, test cart module. So here we are focusing on the individual features or modules. However, in BDD, the focus is on the end-to-end behavior of the application. How the real user will interact with the application, what actions the user will perform, and what outcomes the user will expect. Basically, it focuses on end-to-end user behavior or journey. However, the traditional testing focuses on individual features like login page, registration module, search functionality, and so on. None of these define the behavior of the user. None of these define how the user will interact with the application. Let us take one more scenario. Imagine a user comes to the application and searches for a product. But this time, the user is not registered. The user adds an item to the cart. During checkout, the application asks for login credential. The user creates a new account and then completes the payment. Again, the entire user journey is one behavior. And this is exactly what PDD focuses upon. Once the behavior is defined, the next step is to automate this behavior using some automation framework like Selenium, TestNG, Behave, etc. One of the most important things in BDD is that behavior is usually written by stakeholders, business analysts, product owners, or people who understand the business flow. And they write these scenarios in a very simple language called Gherkin language. So this Gherkin language is used to write the behavior of the application or different scenarios using the plain English language. Let us understand the Gherkin language in detail. Gherkin is the language used in BDD to describe the behavior of an application in a simple and readable format. The best part is even non-technical people can understand it as Gherkin is in natural English language. That means developers can understand it, testers can understand it, business analysts can understand it, and clients and stakeholders can also understand it. So Gherkin acts like common communication language between technical and non-technical teams. Let us understand how to write Gherkin file. So let us go to our Visual Studio. Here I've created a folder BDD underscore code. Inside this folder, let me create a Gherkin file. A Gherkin file is called as feature file and it usually has the extension .feature. So let me create a Gherkin file for login module and name it as login.feature, as dot feature is the extension for the Gherkin file. Now, every Gherkin file starts with a keyword called feature, because in Gherkin file we define the feature which we want to test and various user journey or scenarios or user behavior we write inside this feature file. So feature represents what functionality we want to test. Inside feature, we write different scenarios. A scenario represents one user behavior or one test case. Okay. So let us see step by step how to write a feature file. So a feature file starts with a keyword called feature, feature colon login functionality. So I'm going to test login functionality for which I am writing this feature file. Hence, I have named it as login functionality. So once you define the feature you want to test, the other thing which we want to define is the scenario. So next keyword is scenario. Scenario colon. So in scenario, we write the different user behavior or different user journey. One scenario represents one test case. The scenario which I want to test here is successful login. Let us save it. After scenario, for this successful login, I will need to write the user behavior or user journey, which means I will need to define step by step the actions which user performs. Okay. So for that, we use keywords like given, when, and then. So let's say given the user is on login page. This is given. Given is the keyword used to define what is the current behavior, what is already given. It represents the precondition. So here the precondition is the user is on login page. Now the next keyword is when. When represents the action which user performs. So here, once the user is on login page, the action which user wants to perform is the user enters valid username and password. So when represents the action which user performs. The next keyword is then. Then represents the expected behavior what user expects. So then the user should navigate to home page. This is the expected behavior from the application. So let us look at once again. The feature represents the functionality or feature which user wants to test, which is login functionality. The scenario represents the actual test case or actual user behavior which user wants to perform. For a particular scenario, we have a set of instructions using given, when, and then, which define user behavior. So given represents the precondition. The user is on login page. When represents the action which user performs, which is the user enters valid username and password, and then represents the expected result from the application. The user should navigate to home page upon login. If we see, this file is not indented, and if we want to make it more readable, we can use a plugin which is there or the extension. So let's say cucumber, type here cucumber Gherkin full support. Let us install it. Click on install. Once this is installed, go back to your feature file and you already can see the different colors which are highlighted. Click on save and you will see that your file has become indented. So feature is the parent. Inside that we have multiple scenarios. We can have multiple scenarios. In this case, one scenario is present, but we can also have multiple scenarios. For every scenario, we can have set of instructions using given, when, then, etc. Okay. Let us create one more scenario. Let us write scenario. And let's say in this case, I want to verify unsuccessful login. Sorry, unsuccessful login. Enter. Then given, again, it is the precondition. User is on the login page. When represents the action which user performs. So in this case, let us say user enters invalid username and password. Then user, this is the expected outcome from the application. User receives error message. Okay, let us click on save. The plugin is taking care of the indentation. So for one feature, we have defined two scenarios. This is a BDD file or behavior driven development file, or we can say this is a feature file which is written in a language called Gherkin. So the language where we define keywords at feature, scenario, given, when, then. So this is Gherkin language in which we have defined the BDD. Now let us understand few more keywords which Gherkin language uses. For that, let me create one more feature file with the name product purchase dot feature. Now let me create a feature for product purchase. Let me create a scenario. The first scenario is successful payment with invoice issue. Let's write given condition. Given is the user has added products to cart. To the cart. This is given condition. Sorry, we don't write colon after given. Then when condition we will write when the user completes payment, then the order, this is the expected outcome. The order should be placed successfully. Now, we also want to validate something else. I said when the user completes payment, the order should be placed successfully. But I also want to validate that invoice should not be generated if email service fails. This is my another condition, that email should not be generated, invoice should not be generated if the email service fails. Okay, along with this then condition, that is the another condition which I want to validate. How can I do that? We can do that using a keyword called but. Okay, but is the condition. But keyword is used to represent a negative condition, an exception, or something that should not happen. Okay, it improves the readability when we want to express contrast in the expected behavior. Okay, so let's say there is a exception condition. The invoice should not be generated if the email service fails. So to represent this scenario, I've used but keyword. Okay, let me click on save for the formatting. Let us learn about another important keyword in Gherkin language, that is and. Sometimes we want to combine multiple actions or conditions. For that, we use and keyword. Let us see that. In this current example, we are saying when the user completes payment, then the order should be placed successfully. But I want to add one more condition, and the payment confirmation should be displayed. So what I am validating? The order should be placed successfully and the payment confirmation should be displayed. But the negative scenario is the invoice should not be generated if email service fails. So in this way, these two conditions are combined with the help of and keyword. Now, let me add one more scenario to my feature file, which is successful payment with invoice generation. In the previous scenario was to test with invoice issue where invoice was not generated. This scenario is to test the successful payment with invoice generation. So how my scenario looks like? Given the user has added products to the cart. When the user completes payment, then the order should be placed successfully and the invoice should be generated successfully. This is my one scenario. Now, if we compare the two scenarios, we find that the given condition is common between these two scenarios. And I am having to repeat this given condition. I need to repeat this given condition. If I was supposed to add more scenarios in this feature file, still I will have to repeat this given condition, because to check the product purchase scenario, I have to start with this given condition. How can I avoid this repetition of the given condition? The answer is using another keyword, which is background keyword. So what background keyword does, if some steps are common for multiple scenarios, instead of repeating the same steps again and again, we write them once inside the background condition. So we can write the given condition after background, and I can remove it from my scenarios now. Let me save it, format the file. So I have background given the user has added product to the cart and then rest of the scenarios. Before executing each of the scenarios, it will run the conditions which are given in the background. So when we are running this scenario, first background will be executed and then the remaining steps will be executed. Similarly, for scenario 2, before running this scenario, first background will be executed and then the remaining set of instructions in the scenario will be executed. So this is the advantage of background, that we do not need to repeat same steps across all the scenarios. So we have learned how to create a feature file, how to write different scenarios, how to write the background. We have seen various keywords used in the Gherkin language: feature, background, scenario, given, when, then, and, but, and so on. So the next step is how to automate this. So far we have written the user behavior. But how to programmatically automate this user behavior? How the execution of this user behavior will happen? So this is the next part which we are going to learn is the step definitions. So for every step which we define in our feature file, we have a set of code or a piece of code tagged to each and every step. So when we run our feature file, those code snippets which are tagged to this particular instruction or feature file step, those code will be executed when we will be running the feature file. Let us see it in details. Step definitions. This is one of the most important part of a BDD automation framework because feature files alone cannot perform automation. They only describe the user behavior in plain English language. Actual automation happens inside the step definition file. So what are step definitions? Step definitions are programming methods that connect Gherkin steps with automation code. Feature files describe what should happen. Step definition defines how it should happen because it contains the automation code. So let us understand how the feature file and how the step definition file are related. Let us take our simple example of login feature file. So feature is login functionality, scenario is successful login, and we have set of instructions. So given the user is on login page, when the user enters valid username and password, then user should navigate to home page. This is my feature file. Now let us write the step definition for each step mentioned in the feature file. So step definition we write for various steps inside the scenario. So what are the steps? Given the user is on login page, which is given statement. For that, we create a folder which is step definitions. Inside that, we have created a Java file login steps.java. Here we have imported the Cucumber libraries because we are going to use Cucumber. Then we have created a Java class login steps inside which we will write the code for each instructions mentioned in the scenario. So my first instruction was given the user is on login page, which was the given statement. So I have used the annotation @given inside which I need to provide my statement, and we need to write a Java method inside which we can write our automation code. So here we have used driver. So you can write your automation code for each of the given statements the way you want. So for sample representation, we have created a Chrome driver and we are using a get function to open the login page. So the idea here is to explain not the automation code, but how the BDD framework works, how the feature file and the step definitions are connected to each other. That is the scope of this course. So I'm not focusing on the automation code. I'm focusing on BDD, step definition, feature file as framework, how these work together. Okay. So here we have written the given statement, and inside that we have written the automation code to open the login page. Similarly, the next statement is when user enters valid username and password. So this string we will map to the when condition @ when annotation and provide the same string. And there will be a method tag to it which will have the automation code to enter username and password. The next step in feature file is then condition. The user should navigate to home page. For that, we will use @then annotation and the method will specify the assertion. So this way, each and every instructions written in the scenario is mapped to a Java code or Python code, whichever framework and language you are using. It is mapped basically to the automation code. So far, we have learned about feature files, Gherkin file, step definitions. Now, the next question is, how do we actually execute everything together? How these two files, the feature file, step definitions, how do they work together? How do they execute together? How does the framework know which feature file to run, which step definitions to use, where reports should be generated, which scenarios to execute? The answer to all these questions is test runner. What is a test runner? A runner is a special class or file responsible for executing feature files. So a test runner executes feature files. It connects the feature files to step definition. It starts the automation execution. It generates reports. So all this is the responsibility of the test runner. In simple words, a test runner controls the execution of entire BDD framework. Let us understand test runner with TestNG and Cucumber example. So this is one of the sample test runner files where we have used Cucumber and TestNG. So we are using the annotation @Cucumber options. This annotation contains all the framework configurations. Inside this, we have the location of the feature file, we have the location of the step definitions, we have the plugins, right? Let us see each one of them one by one. So like we know, we have already understood Cucumber options contains all the framework configurations. Inside that, we will have all the framework configurations. What are those framework configurations? The features, the feature files, which tells Cucumber where the feature files are located, right? So here we can give the path of our feature files. Then the next thing is glue. What is glue? Glue tells Cucumber where step definition files are present. Cucumber searches this package. Whatever we mention here, Cucumber searches this package to match the Gherkin steps with automation methods. Okay. Gherkin definitions. These are the definitions with step definition methods. So basically, feature defines where my feature files are. Glue defines the package in which the Cucumber should search the step definitions. And then the next thing is plugins. Plugins are used for reporting, for output formatting. For example, there are two plugins which are mentioned here are Pretty, which makes console output cleaner. The next one is the HTML, which generates the HTML report after execution. You can open this report in browser to see which of the scenarios have passed, which have failed, what are the execution details, and so on. The monochrome option improves the console readability. This is just for us to be able to read the console properly. Internally, how the execution happens when you run this test runner file, the TestNG starts the execution. The Cucumber reads the feature files. It finds the matching step definitions. It executes the code which is there inside this step definitions. It captures the results. It generates the report. So this way, how the three things are feature file and step definition work using the test runner. So these are the three important components in the BDD framework which help us to define the behavior, which is there in the feature file, to define the automation code, which is there in the step definition, and to make these two things run together using the test runner file. I hope you have followed this lecture and you have understood how to define the feature file, how to define the step definition, what is the use of test runner, how the BDD works together.